Let's see how we start. So Jeremy Anderson from NovaTech Automation. It says cost-effective SCADA, so I'm really curious how that is. And how to link that to the DR and IoT devices. So enlighten us.
All right, thank you. My name is Jeremy Anderson. I'm the Senior Vice President of Engineering for NovaTech Automation, I'm based out of Pennsylvania in the States. NovaTech Automation is an automation company that's been around in the US since about 1981. We started the first digital substation multimeter, SCADA meters in the substation back in 1981. And then moved on to RTUs, digital I/O, and so we are one of the major U.S. vendors for RTUs, clocks, switches, and that in the United States. I'm not going to do a lot of marketing stuff, so I pulled out all of the marketing from this. So I'm going to talk just a little bit about the evolving grid. I think everybody understands the evolving grid and what's changing, but I like to just start my talks always and remind everybody what we've seen over the last 100 years and what now we're seeing that is so drastically different. A little bit of the challenges of some of the traditional SCADA systems and how we could use virtualization up at the SCADA system to reduce some of the costs and complexities of SCADA. Some deployment strategies for virtualized front-end processors, and a use case that I'm going to cover that we've done in the US. So I think, as everybody knows, for the last 100 years or so, the grid has been relatively the same. We produce energy at large generation facilities. It travels long distances, maybe not as long here as sometimes in the United States, where we travel thousands of miles. And then distribution grid down into the final houses, in industry, that sort of thing. The scale of that has grown drastically over the last many years, but it relatively stayed the same until over the last few years, I say 10, 15 years now that it's been really growing, but even more so in the last many, where we have solar, wind, geothermal, these distributed energy resources that then end up at all over the place, right? They're not in the same locations as we had big coal plants. They're not in the same locations as hydroelectric. They're in a field somewhere. They're in on top of a large building. They're distributed all over, right? Makes forecasting, managing the grid very difficult. And their output isn't flat. We have sun, sometimes we have wind, sometimes it's all over the place. And then we've added things that use energy a lot differently, like EVs, right? That's so drastically different from what we've done for so long that we're having to deploy thousands of devices, and how do we get those devices and that data into our SCADA system? So SCADA has a very expanding role in this new idea, right? Historically, it was designed to monitor large substations, large power lines, large generation facilities. But now we have to support those thousands of extra devices. You have a lot more reclosers. You have all the DERs that are being integrated. And some of those devices speak different protocols. They have security considerations you might need to take into account. And it becomes very complicated, and especially as you look at how SCADA has traditionally operated. So what are some of the challenges that this brings into a traditional SCADA system? Now in the US, and maybe I don't know the European grid as well, but we have thousands of utilities. Some of those utilities are 1, 2, 3 substation size. So their SCADA system is very basic, and they don't have a lot of money to spend on enhancing that SCADA system. But the DERs are often found in those communities in the US. So in rural communities where you have a cooperative or a municipal utility, there's lots of land. So it will be a wind farm or it'll be a solar field that's added there. And those utilities can't afford to bring all that data into the SCADA system, considering many SCADA vendors, at least on a smaller scale SCADA, charge on a per device connection. You know, how many devices are you connecting? How many tags are you going to have? What protocols are you going to use? And that cost can add up very quickly. And there's protocol limitations. Some SCADA systems might only support DMP 104. Maybe they support 61850, but again, you add cost by adding that. Maybe they support Modbus. Maybe they don't. Again, the utility would have to go add those protocols, add those connections, add those tag counts, and that can add up in cost very, very quickly. There's also data sharing restrictions, right? How do we get all this new data to all the places it actually needs to go? And traditionally that's been SCADA system brings that data in, and then maybe we share it to Pi, maybe we share it to some other system, and that's often done through database queries, that sort of thing. But how do we get to the cloud? What if you want to send it MQTT and you want to send data that way? What if you want to, I like to say, massage the data before you send it somewhere? What if you want to filter some of that data? How are you going to do that in your SCADA system efficiently, effectively, if you're adding thousands of devices and hundreds of thousands of tags? How do you do that? So one of the things we considered was virtualization. Now, NovaTech Automation is a member of the vPac Alliance, which is looking at how do we virtualize the substation. Involved in digital substation, if you've been in any of the digital substation tracks, there's been a lot of talk of virtualization at the substation, right? And we sat down and we decided where else would virtualization of maybe a substation product help? Where else could that be used? And quickly, what is virtualization? I not to think that everybody doesn't know, but in case anybody doesn't know, it's taking that physical asset and taking its software and being able to run it on different hardware, right? Virtualizing it, putting it on a hypervisor, and running that, where you can potentially run many, many virtual machines on a smaller subset of physical devices, right? So with virtualization, there's different deployment architectures. You could do something as simple as single server deployment, multiple VMs on some hypervisor. In this case, I've just shown ESXi from VMware, but there's open source hypervisors. There's hypervisors from multiple different companies out there. And then that runs on a server. So single server, very basic architecture. But you can get into some very complicated architectures that allow you to have high availability. You can have much more redundant application support with this. So running something where you have multiple servers, a network attached storage, you have a management software that can manage all your virtual machines. Virtual machines can then be migrated or shifted or fail over to different clusters or different machines. And this allows you to have really high availability and really high uptime for a virtualized asset, instead of a physical device that if the power supply fails or you have some issue with the hardware, you're down. In virtualization, you can have almost 5 nines uptime with those devices, right? So what we decided to do is take our RTU that we've been building for many years and virtualize it. And of course, our first thought was we're virtualizing this for the digital substation, right? We're gonna, utilities are gonna take substation and they're gonna run an entire substation on 3 servers, and they're gonna remove all the hardware, and they're gonna have merging units and all that, and we're 100% on board with that. And like I said, we decided, what else could you do with a virtual RTU? So we thought, as we looked at the SCADA systems and realized so many of them don't support all the protocols that might be needed. They don't support all the security that might be needed. We thought, what if you took a virtual RTU and you put that up at the enterprise? You put that as quote-unquote front-end processor to a SCADA system, where you could talk to tens or hundreds of thousands of devices in all sorts of protocols. Maybe you have a device that must be talked to using DNP Secure Authentication version 5. Well, there's, I'm going to guess, almost no SCADA system that supports that very well, but an RTU in a substation does. So virtualizing that RTU gives you that access to these protocols, these security requirements that you could do. Being able to, like I said before, massage that data. Maybe you need to scale that data so you can send it off to a different system before it, and also send it to your SCADA master, right? So being able to have logic functions that you could run, being able to have math functions that you could run, all these things that are inherent by design in almost every RTU, modern day RTU out there, that aren't necessarily easy to do in a SCADA master at this time. Licensing fees. Like I talked to before, one of the big costs of a SCADA system is its licensing fees. Most RTUs are buy it and use it. Our virtual RTUs, same way. There's no licensing fee. There's no, you want to add, it reduces the cost. You have all the protocols you need, whatever those may be. And that multi-system distribution. Let's say you want to bring in all these data points, some to SCADA, some to Pi, some to some DERM system, some to some other analytic software, all in a different format, all in a different protocol. You have that option at that point. So idea being, installing a virtualized RTU on servers, talking to all these edge devices, your standard reclosers, maybe even fault locators, solar at a house, right? You want to be able to bring in all these assets. We have a requirement, actually in the state that I live in Pennsylvania, that the Utility Commission in Pennsylvania has required any household that adds solar to their house must allow the utility to communicate directly to their inverters and bring that data back into the system. If they don't let them do it, you don't get solar on your house, right? Well, how do you bring that data back? Most of it's Sunspec Modbus, maybe it's just plain Modbus, maybe it's something proprietary. SCADA system isn't going to handle that. So there's some benefits as well to adding a virtualization and a front-end processor like this to your SCADA system, right? You can have some deployment strategies of how you bring this data in, how you manipulate it, but also, maybe you're only going to bring in data from this region, and then you're going to segregate that data from another region and another region. And so that way you can make changes to data, you can turn on and off data access based on region. I mentioned high availability and redundancy. It's much higher availability when you run virtual machines in this way. And then again, the security considerations, right? Do you need to use 61850 with 62531 security, TLS security to a device? Well, your SCADA system may not support that, probably doesn't support that, but an RTU does traditionally, and a virtual RTU in that sense would also. So now that one device you could never connect to before, you can bring that data in securely, using TLS. You can have VPNs. You can build custom firewall rules that are inherent just for maybe a specific type of device. So on a case study, we have a large customer in the US that came to us, and they said, we have this old SCADA system. They have a big SCADA system, and then they had a separate, small, old SCADA system that was completely by itself. They were bringing in about 5,000 distribution devices in their system, and it was old. They needed to upgrade it, and they wanted to add in another about 15 to 18,000 devices as well that they've been wanting to get data from on their distribution side. But they didn't want to bring that all in directly to their SCADA system. And so they came to us and said, what could we do and how could we solve this issue? So this is what kind of brought us at NovaTech into the idea of what if you front-ended your SCADA system with a virtualized system. So they needed, like I said, approximately 23,000 devices to be brought in. Those devices some of them were DNP, some of them were Modbus. They had about 1,000 devices that only talked DNP secure authentication. You couldn't talk to them with any other method whatsoever. And then I believe a few other devices that had some other random protocols that we supported. And we were able to come in and say, okay, let's put this together. So what they did is they deployed 23 virtual RTUs in front of their SCADA system. Each one of those virtual RTUs, they divided up to have about 1,000 devices on it. But then they came to us and said, but we also need to make sure that if this system goes down, that it doesn't, right? They wanted extreme high availability. So at their primary control center, they had 2 clusters of servers, very large clusters of servers with network text storage. And so we implemented a redundancy protocol where there would be 23 virtual RTUs running on one cluster, the same 23 virtual RTUs running on another cluster, always running at the same time, always talking to all the devices. Only the primary side would be active, sending data up to their other systems. If for some reason that VM stopped, the other one just took over, right? Perfect, no problem, no outage, they could see it. But this utility happens to be in Washington, D.C. area. So they're very worried about what happens if their primary operating center goes away or has some attack on it. So they have a remote underground disaster recovery center. So they asked, how do we also make sure that if the primary operating center goes away, that the disaster recovery center can come up and do everything that needs to be done. And so at the disaster recovery center, they have another 23 virtual RTUs on a primary cluster and 23 backup virtual RTUs on a backup cluster. And all of that talks to each other all the time to keep data in sync, to keep configurations in sync. But at any time, anything can go down and the other servers will pick that system up. And the other thing they decided was, what do we do when we add new systems, right? They want to add cloud-based analytics. Well, their SCADA system didn't support MQTT, so they wanted to be able to send data via MQTT. They want OPC UA. Their SCADA system didn't support OPC UA. Adding that or adding another system was cost prohibitive. So they were able to go in and do all of this for a fraction of the cost of adding more protocols, more devices to their SCADA system. Their SCADA engineers barely had to touch their SCADA master side. They had to bring in the data, but they didn't have to connect to the devices. They didn't have to build that connection infrastructure. So this made it, instead of 23,000 devices that the SCADA system is paying to talk to, it's talking to 23 devices at any given time. So, like I said, just a very quick discussion on this. A large SCADA system, often you have unlimited devices, you have unlimited tag counts, but some SCADA systems are not like that. And instead of having to add that, adding this virtualized front-end processor idea allows you to bring all that data in as it grows and grows and grows. It's extremely scalable. You need to add more devices, you can spin up another VM in minutes, right? You can clone VMs and spin them up, load them, and be done in a matter of, less than a minute sometimes, depending on what you're doing. So it's also very flexible. Industrial protocols, all these things that we're starting to see that aren't traditional SCADA, being able to bring that data in now is very important. We talked a little bit about the reliability, right? The high availability, all of that is extremely important. And it really does kind of future-proof a SCADA system. Without having to rip out or upgrade your SCADA system, you can now have something on the front end that is easily upgradable, easily supportable. Many SCADA systems charge for their firmware updates or their software enhancements, where in like this case from us, there is no charge ever again for updating firmware, new features, new security features, things like that. It's all part of the initial purchase of the system. So that's kind of my presentation. Open it up for any questions you guys have.
Thank you very much, Jeremy. Any questions?
Hi, I just heard you mention open source in the context of your hypervisors that you could put on this. Have you investigated like the Linux Foundation for Energy CPAF at all?
Yeah, we are actually in the process this week of spinning up CPAF, working with them, and then figuring out what it will take to run on it. Right now we support ESXi and Proxmox. CPAF will be relatively simple to support as well. And then, we're open to looking at any KVM-based one, Red Hat, those type. But we have customers that want Hyper-V, few others. I know, right? But, you do what the customers, you do what the customers want sometimes. But yeah, we're an open source company. We do a lot of our stuff open source, so we're very open to doing that. So.
I like the presentation, thank you.
Thank you.
Have you considered, or have you done anywhere, because I've seen at the start you have put like the EVs and the V2Gs, which is like where normally the meter is embedded within the assets.
Right.
Have you had any use case where you connected from these meters into a virtual RTU, and can you talk about it, please?
We have run into a little bit of that in more in some pilot applications, right? Where we're pulling Modbus data back from a virtual RTU, but that wasn't really at the front end. It was some industrial applications where that was charging stations or small scale battery storage, stuff like that. But we see that as a real opportunity because it's hard to get that data. Most of that data goes to somebody's cloud, right? And the issue though is connecting to that device, and often it is proprietary communications protocol that they've implemented, which I'm never a fan of a proprietary communications protocol. But that's why we've looked at MQTT as an option, right? Is to maybe be able to pull that from the cloud back in as another way to do that.
Thanks. It's very interesting to see the physical arrangement of moving to virtual. But my question is, when you're bringing all these things together, the different types of protocols, I'm always interested in what is the information model behind this? Because I've looked at MQTT and it's transport, but I think of it as the Modbus of the internet. You can do anything you like with it. Yep. Which means everybody's Modbus is different, everybody's MQTT is different, which is a configuration nightmare.
Yes.
And when I look at the other things you've mentioned, we've got DMP3, 104, very flat measurement structures.
Right.
61850 goes into a particular way of structuring it. They're not always compatible.
They are not.
There are moves ahead to have OPC UA with a mapping to 61850.
Yep.
I hope that will be coming out at the end of this year. But I'm interested, yes, you've got all the data into your virtual RTU, but how do you get it into the same type of information model?
Right.
And is that the same information model that we use in the SIM? Or
could it be?
Could it be?
Yeah, so what's interesting about the way we do stuff internally in our virtual RTU, including our hardware RTU, is the same as as we bring in data from different protocols, we normalize it into a very basic database internally so that we don't worry about the actual model as much, so that when we provide that, let's say, bringing in something like Modbus and then needing to send it out 104 or 61850. By normalizing it in the RTU, we just follow the standard on the way out, right? So we can very easily craft and follow any data model of any protocol from any protocol. Because yeah, that mapping of, like if you say OPC to 61850, it's not easy. But if you take all that data and make it very flat and very basic, you just basically scale it down and scale it back up, it's very clean that way. And where we saw, and we've always saw the most complicated part of that was scaling of analog values, right? Because the scale factors at Modbus, being 12-bit and going to something that's 16-bit or maybe even 32-bit, it's very difficult to really do a very good scaling, or for people to understand scaling often. So we did it in a percent full scale kind of idea, right? So it doesn't matter if it's 12-bit to 16-bit. If it was 50% of full scale at 12-bit, 50% is full scale at 16-bit. So by flattening it, it makes it very, I say very easy. It makes it easier to do that.
I'm surprised to hear you talk about 16-bit and 12-bit, because in my world, people talk about floating double.
Yeah. Right.
As I understood, you usually understand the format of the fields, components, and assets. But to formulate maybe a little differently, the question to ask is the translation with the SCADA and the business logic, which might be touchy, even though you go from that, So, do you have experiences return on how difficult is the integration of your front end with a SCADA?
So what we've seen is it's because in our use cases, what we did was take our substation RTU that customers already had in the field and virtualized it, and using that same technology and that same idea at the front end. Their implementation was, they already understood it. They already knew what to do, very clean. And so it didn't take much effort. I would say the most effort for, in the case study that I was presenting, was actually licensing what ended up being 92 virtual RTUs, generating a license request file for each one, sending it in to us, getting the license file. That was the most work of all of it. The rest of it was very simple. It's drag and drop points, it's building templates, that sort of thing, and being able to deploy. So now, from someone that might not know our stuff in general, you have to learn it, but it's quite user friendly. So.
Roy Silva, Hitachi Energy. Do you provide, I'm assuming the answer is going to be yes, but I'm not sure, therefore I'm asking. Yeah, like most traditional RTU suppliers, I'm assuming you provide tools to import, export data from the data engineering point of view.
Yes.
So that you can sync, you don't have to manually enter the same addresses on SCADA and on your RTU.
Yeah, absolutely.
Yeah,
I mean,
so
we have ways of exporting the data. We have ways of importing data.
Yeah, so it's business
as usual. It's
business as usual.
Yeah, and that's the neat thing. It's an RTU, right?
An RTU.
Yeah.
Thank you.
Yeah, that was our real goal with this, was do what people already understand. Don't make it crazy and different.
The question is, you support all the SCADA protocols, but is it also possible to have a Kafka interface to the RTU?
Which interface?
Kafka.
Kafka?
Kafka.
Oh, there would be. We don't have that now, but we we write all our own protocol, all our interfaces. We write APIs for different customers for different things. So there's all sorts of things we can add to that. But currently it's not supported in this version.
Hi, I'm Maxime from RT, the French TSO. One question regarding your license model. In your use case, does the utility have to pay for the 23 virtualized on the backup? Does he pay yearly? Does he have to pay for support? Or?
Okay. Perfect. So the way we've done it, and whether it's right or wrong, we'll learn over the years, is it's in that case, it was for the 92 actual deployed, it was 23 licenses. So all the backups, because they're not actually doing anything at the same time, they're just there. It's only 23 licenses. Those licenses are perpetual, 10-year licenses. There is no support fee. We kept the same model that we keep for our substation RTUs. 10-year support, 10-year firmware updates, all of that included in the initial cost. So I'm not sure how it is in Europe, but in the US, substation guys hate annual fees. They absolutely despise them. They don't want them. So we kept that same model even at the enterprise.
We've got a lot of questions.
Oh, yeah, I'll take it. You know, that's why I made the thing short. So.
So Anthony from SVP of Automation. My question is almost linked to the one from Maxime. Sometimes when I speak to hardware manufacturers, they feel that virtualization will, it's a problem because you will sell less hardware, because you could duplicate it on one hardware and create, I don't know, maybe 10 virtual RTUs.
Right.
So as you are making RTUs before, physical ones, do you see it as a kind of internal competition to sell also virtual RTUs? Or?
There definitely was a little bit of internal struggle inside the company when I first proposed doing virtualization. I was a very high proponent of virtualization. But yes, we are a hardware company. We've been a hardware company for a long time. We'll continue to be a hardware company for a very long time. But we realized, and I was able to convince, that we don't want to be that kind of company that sticks to hardware, and then finds out, yep, it is really going to go that way, and now we're way behind, right? Because it's not although virtualization is not particularly difficult, to make sure it runs on many different hypervisors, to make sure all of that, it takes time, right? And then there are applications we would have never got into. There was no way this customer was going to buy 92 physical boxes to do this application. Not a chance, right? So virtualization got us into other areas. So as a company now, we are very big proponents of virtualization. We understand, yes, could that hurt us? But there's always going to be a need for physical IOs. There's always going to be a need for some physical interface to stuff. So, yeah. But it was there's still some questions, you know.
Oh, great presentation.
Thank you.
That's Nicholas from TSO in Norway. I have a question about the hardware RTUs and the virtual RTUs. Can you load a configuration from the hardware RTU directly into the virtual RTU to say use in testing and commissioning in the whole substation virtually?
Yes, that was another side thing we realized was quite useful with virtualization, is that we developed the virtual RTU based on our best-selling physical RTU, and found that some of the customers loved that idea because they can now run virtually the RTU on at their desk even, without having to have physical RTUs there, and test the substation, do all that, and then deploy that same file down to the physical RTU in a substation. So for a testing purpose, it's actually quite useful. And we learned internally, actually really useful for us as well, for our project engineers and that sort of thing. Instead of having racks of our equipment and rolling it around to build up stuff, you could do it all virtually quite easily. And it's made a difference in that sense too. So, one-for-one configuration swap is not a problem.
I just wanted to follow up on that question. So, when it comes to testing efforts, do you have some kind of indicator on how much time or effort is saved when we go virtual for testing?
Not off the top of my head, really. Honestly, I'm not sure it's a huge time saver necessarily. It might be to an extent if you're trying to build up something when you can do a lot of it virtually, you'll save time in plugging in, wiring things, grabbing equipment and that sort of thing. But once it's up and running, it operates identically to the physical hardware. So from a testing standpoint, it's relatively the same, at least from my idea of it. So, but space, being able to do different things with it does save that effort.
Thank you.
It's just a comment on the last speaker. So what you raised is an interesting point in testing these systems is you have a virtual RTU, but to test it, it's part of a bigger system.
Right.
And that opens the door to what is possibly new markets, because you now need to, instead of having physical I/O and switches, you can now have a virtual thing. And if it's virtual, it's probably easier to make it automated. Yes. In a software environment.
That's a good point.
And potentially you can also have the virtual SCADA system to check what is the data actually arriving where it should do. So this is opening the door to a completely virtual system, which is also known as a digital twin.
Right. Yeah. Yeah, and there's a decent amount of test software out there that can, mimic IEDs and that sort of thing, and running that virtually next to this, all on one server, can really, over time you could really get there and have a nice test system. Well, thank you guys.
Really? No?
You have one.
I have one actually. I was intrigued by the picture that you showed, that you have multiple devices like the EV, the PV, etc., and the original sensors and actors.
Right.
What I see in Europe often is that system operators tend to split the communication of their, let's say, the primary goal of the substation that funnels into the SCADA and, let's say, oil sensors or EVs or other DER or things that are not primarily relevant for the SCADA, and split that communication. I understand you can do it all via one virtual RTU, but you can probably also do it via two or something like that. Suppose you do it via one. One of the key reasons that they like to split it is the priority of information, that if you have EVs that you cannot control, if something goes wrong over there, that you overpower the actual information you want to get for your SCADA.
Right.
Suppose you have one virtual RTU, how do you manage that to avoid that we lose the relevant information?
All right. So what's interesting and a thing we did years ago in our hardware RTUs and carried over is we had virtual RTUs inside of our hardware RTU. And so now I guess you would say we have virtual RTUs inside of our virtual RTU. And so you can, so nested virtual RTUs. And so you can actually take different data and map that into what would look like its own RTU and have different class structure on the data. Let's say I'm more versed in DNP than some protocols, but how different deadbands on analogs and all that kind of thing, and filter that data based on different virtual RTUs if you wanted to as well. So so you could limit some data, you can map that data to different devices, all that kind of stuff. So.
Thank you. Then I would say Jeremy Anderson, thank you very much for your lovely Q&A.